Hey, thanks for tuning in to another episode of Check This Out Mathematics. And I encourage you to subscribe to the channel and give some comments down below and give me a thumbs up if you like these videos. And we are continuing our lessons on logarithms. And in this episode, we're going to be solving equations involving logarithms. And so let's do this first example. Here we have 3 log base 2 of x equals 18. Okay, so example number 1, 3 log base 2 of x equals 18. And so now what we want to understand when we're solving equations involving logarithms is that this log portion of the equation, this is called the variable expression. Okay? The variable expression. And so the variable expression is the portion of the equation where the variable is. Okay? And so the concept is to solve for the variable expression and then solve for the variable. Solve for the variable expression. Then solve for the variable. Okay? So this is the approach that you want to take when solving logarithmic equations, is to solve for the variable expression, then solve for the variable. Okay, and you're going to see what we mean by in this example here. So imagine that this was just 3z equals 18. So here's our logarithmic equation. And what you want to imagine is that this was just 3z equals 18. And so wouldn't you divide each side by 3 and say z equals 6, right? And so there's the variable, and we're going to solve for that variable by isolating it, by getting it by itself. And that means, in this case, dividing by what is surrounding the variable, which is this multiplication by 3. And so we're going to divide by 3, and now we have simplified the equation just to say z. Okay? And so we're going to do the same thing here. So don't be like wondering about what do I do with this log thing? No, it's a variable expression, just like z is the variable. And so we're going to do the thing that we would usually do, which is to divide by 3. Okay, so we would say log base 2 of x equals 18 divided by 3. Okay, so this is being multiplied by 3, and so on the other side I'm going to divide by 3. Okay, and you can show it on both sides if you like to do that. Okay, so that's what we did. We divided by 3 on both sides. Okay, and so now then we have log base 2 of x equals 6. Okay, and so now we have solved for the variable expression. This is the variable expression, and we have the variable expression by itself and this value on the other side. Okay, so now this is where we're going to use the definition of logarithms. Okay, so let's remember our definition of logarithms. That if you have b to the n equals x, then that implies log base b of x equals n. Okay, this is our definition of logarithms that we presented earlier in an earlier episode, and many earlier episodes. And so this is the exponential expression that implies the logarithmic expression. And the logarithm is asking, what is the power? What is the power that makes b become x? And since it's the n power that makes b become x, then the log base b of x is n. Okay? And so when we have this definition of logarithms, remember that we can make this round trip. Okay? So when we have log base b of x equals n, we can make this round trip from the base to the exponent, or from the base to the power back to the argument, and get b to the n equals x. And so that's what we're going to do next, is we're going to use that definition of logarithms to change this from a logarithmic equation to a exponential equation. And so we're going to apply this round trip, and we're going to say log base 2 of x equals 6 gives us 2 to the 6th equals x. How do we find x? By taking 2 to the 6th will give us x. Okay, and so now we have solved for x. You see, we have said 2 to the 6th equals x. Okay, and we have solved for x. And now the last thing to do is, what's 2 to the 6th? Okay. All right. So that would be 2 times 2 times 2, and another 2 times 2 times 2. And so if we remember that 2 times 2 times 2, that gives us 8. 2 times 2 is 4, times 2 is 8. And so now here's another 2 times 2 times 2. And so that's 8 times 8. And so 2 to the 6th is 64. Okay, that's a nice ring to that. Okay, so x equals 64. Okay, and there's our solution. We solve for the variable expression, and then we use the definition of logarithms and made our round trip to solve for x, and then we went ahead and did 2 to the 6th power, and we got 64. All right, so let's, you know what helped me as a student is to check these problems and see that they made sense. That's the number one job of math, is to make sense. Do you remember what the number 2 and number 3 job of math is? Oh yeah, that's right. You're right. The number 2 job of math is to be easy. And the number 3 job of math is to be fun. Because when it makes sense and it's easy, it's fun, right? And you just want to do math all the time and watch math videos and yeah, right. Okay, so let's check this. So we have 3 log base 2 of 64 equals 18. And so here was the original equation right here. And then there was our solution, x equals 64. And so instead of x, we're going to put 64 right there. See, there it is. Okay. And so now we're going to remember, what is the logarithm asking? So the logarithm is asking what power of 2 gives us 64. And that's 2 to the 6th is 64. Okay. So on this side note, what power of 2 gives us 64? And so 2 to the 6th is 64. Let's not take up so much space in saying that, because we're going to run out of room on these slates, Mr. Okay, so this is saying 2 to what power is 64? And so 2 to the 6th is 64. Okay, that's our side note. Okay, so that's what the logarithm is asking. What power of 2 is 64? What power of 2 is 64? And so 2 to the 6th is 64. And so instead of writing log base 2 of 64, we can write 6. Okay, so we have 3 times 6 now. And 3 times 6 is 18. All right, it works. All right, very nice. Okay, now let's do another equation involving exponents. And let's touch this up a notch by doing this one here. Let's see. Okay. So example number 2, we have 3 plus 2 log of 8x equals 9. Okay, put some parentheses here. Okay. All right. So we have a logarithmic equation here, and we are going to solve for the variable expression. This is the variable expression right here that we're going to bracket here. Okay. And so what you want to imagine is that this equation, there's our logarithmic expression in red there, in that bracket red part. And so what you want to imagine is that this is 3 plus 2z equals 9. See, there's a variable right there, just like the variable expression. Okay, and so how would you solve this equation? Well, you would say 2z equals 9 minus 3. So you would jump this positive 3 to the other side as a negative 3. And then you would say 2z equals 6. And then you would divide by 2. So you would 2z divided by 2 equals 6 divided by 2. And z would be 3. Okay. So we solved the equation, right? Okay, well then let's follow that same approach on the logarithmic expression, on the logarithmic equation. Okay? So we are going to move that this positive 3 to the other side. So we're going to say 2 log of 8x equals 9 minus 3. Okay, so we move the 3 to the other side of the equation. And then we got 6 here. 9 minus 3 is 6. And then we can divide each side by 2. So we're going to divide here by 2, and here divide by 2. Okay, so we move this positive 3 to the other side as a negative 3. 9 minus 3 is 6. And then we divided by 2 on both sides. And we got log of 8x equals 3. Okay. 6 divided by 2 is 3 there. And now you may be wondering what the base is. But it's, it's common knowledge what the base is. Okay? Because this is the common logarithm. The logarithm that every common person uses, right? Whenever they're doing logarithms, right? That's what our people like to do is logarithms, And so this is base 10. Base 10. Okay? The everyday logarithm. Okay? Okay. So we have log base 10 of 8x equals 3. And now we're going to perform our round trip, right? That's what we like to do, is perform the round trip. And so we're going to say 10 to the third is 8x. Okay? Our round trip there. All right, so now let's try to be organized, Mr. O'Donnell. Okay, now when we do our round trip, we're going to do b to the n equals x and change it from a logarithmic equation to an exponential equation. Okay, so this becomes, right here, this becomes 10 to the third equals 8x. All right, so we have 10 to the third equals 8x. Okay, that's our next step there. All right, and so now um, let's do 10 to the third. Okay. So 10 to the third is 1,000. So I'm just going to write it like this. 8x equals 1,000. And then we're going to divide by 8 on both sides. Okay. And so then x equals 1,000 divided by 8. Okay. And so you might be wondering, what is 1,000 divided by 8? And you might want to use your calculator, but this right here is your calculator. Okay? And this right here, your paper and pencil, or your marker and slate, is your calculator. So let's do some calculating with using this calculator and this calculator. Okay? So we have this as 100 times 10, right? And this is 4 times 2. Look at that. Isn't it beautiful? Okay, so what's 100 divided by 4? Well, that's 25. And what's 10 divided by 2? Well, that's 5. And 25 times 5, 25 and 25 is 50, 75, 100, 125, right? 4 25s make 100, so another 25 makes 125, right? Okay. Who needs calculators when you have this calculator? You have a good calculator, it works really well. And when you have this calculator right here, and it'll give you the answer. Okay? Don't put this into your calculator. You can figure it out. Okay. By factoring. All right, so there's our answer. X equals 125. Okay, so you mean to say, Mr. Donald, that this switch hands here. That we did. This is what we have to do. There we go. Okay, so don't cover up your answer, Mr. Donald. Okay, let's touch this up here so it looks nice. Okay. Okay, and let's put, let's hold it like this. There we go. Okay, so here we solve the equation, and we found that x equals 125 there. And so now if we put 125 back in place of x over here, will it work? Sure. That's the whole idea of solving an equation, that's the solution, that when substituted back into the equation makes the statement true. Okay, so here we have 3 plus 2 log 8 times 1,000 times 125. Okay? Equals 9. Okay, so here's the original equation right here. And in place of x, we're going to put 125, our solution. And so there it is with the 125 in place of x. Okay? And so You see what this is called? This is called a conditional equation. Okay? We are trying to find a value of x such that if we multiply x by 8, take the logarithm of that, multiply it by 2, and add 3, we will get 9. So under what condition is this true? And we have found the condition for this being true. It's when x equals 125. So if that's the condition where this statement is true, well, then we ought to be able to simplify this and get 9. Okay, a conditional equation. Okay, and so then 8 times 125, we know that to be 1,000. So 3 plus 2 log of 1,000. Okay, and then remember that this is the base 10. Whenever the base is not written, it's because we understand it to be base 10, and so we don't need to write it. Okay, so what power of 10 is 1,000? That's how you read your logarithmic expression. And so the third power of 10 is 1,000. So now we have 3 plus 2 times 3. And so what power of 10 is 1,000? It's the third power of 10 is 1,000. And so now continuing our order of operations, we're going to do 2 times 3. And that's 6. And then 6 plus 3 is 9. And it works. Okay, awesome. Okay, how about a couple for you to do? Since you are having so much fun and this is making so much sense and it's easy, right? Let's have a couple for you to do. All right. For you. Okay. All right, so let's see. Where did I have another one of these? I guess I'll have to make one up. Okay, so for you to do, we'll have 4 log (3) of x equals let's see 12 no 6 no 8. Okay, that's okay. That's pretty easy, you know. Okay, there's one for you to do. Okay, and then another one for you to do is going to be this one here. 9 log 9 plus 3 log of 2x equals 15. Okay, so work those problems and tell me how you like them in the comments down below, and subscribe to the channel and give me a thumbs up to like these videos, and thanks for tuning in. Mr. O'Donnell signing off.